Alright guys, in this video we're going to be discussing the concept of the distributive property. Now, the distributive property in mathematics is a very beneficial concept that can be used when we're trying to simplify algebraic expressions. Now, to discuss the distributive property, I'm going to do this in three ways. The first is I'm going to mathematically express it. Then I'm going to verbally define it and its nature and behavior. And then I'm going to visually model it. So let me start by stating the claim that if I have some quantity A times a quantity B plus C in parentheses, this is going to be equal to the expression AB plus AC. Now, let me explain exactly what's going on here with the distributive property. We're taking some value A, and we're equally distributing it into each of the individual terms of the expression in the parentheses. But I want to caution you here, because we're not only distributing the value, we're also distributing the sign on it. So we want to be extra careful here when we're distributing. Now, when we're talking about distributing, we're talking about by means of the method of multiplication. So what we're going to be doing is multiplying each individual term by the outside term. So when we distribute A into B, we're multiplying A times B. When we're distributing A into C, we're multiplying A times C. Alright, so from a verbal sense, what the distributive property is to multiply a sum or difference in a set of parentheses by a particular value, and then we're going to be simplifying that expression. Okay? Now, for the intents and purposes of this video and the concept of the distributive property, even though some of the values that are going to be in the parentheses are like terms, I'm not going to simplify the value in the parentheses first for the means and intents and purposes to show the distributive property more clearly. So to illustrate that, let's start with our first example being 5 times the quantity 12 plus 4. Now, one thing that you definitely are going to take a benefit from in terms of getting in the habit of is if a value or a term doesn't have a sign on it, go ahead and put a plus sign there. The reason that this is going to be beneficial is even though this example has all positive values, it's not always going to be the case, and you're going to run into negative values, and things can get a little tricky there. So putting the positive values just keeps housekeeping and bookkeeping a lot more easier. Now, as I mentioned with the distributive property, we're taking 5 and distributing it into the individual terms here of both 12 and 4 by means of multiplication. So 5 distributed into 12 is 5 times 12, which is 60. And then remember, each of the individual terms has a sign on it. So positive 5 times a positive 12 is a positive 60. And then a positive 5 times a positive 4 is a positive 20. Now, notice here that all we have left to do is an arithmetic sum to calculate. And positive 60 plus 20 is 80. Okay, so that's our first example of the distributive property and exactly what's going on. Let's look at our next example where I can visually model it in further detail. Okay, so for this model, what I want to take is the expression 2 times the quantity x plus 4. Now, again, one of the most beneficial things that you can do is put a plus sign on any terms that don't have signs. Now that we're introducing negatives, another thing that you can do that is very beneficial is put a coefficient of 1 on any variable that doesn't have a coefficient on it. A coefficient is any value that is inferred to be multiplied by that variable that is other than 1. Because when a variable is by itself, it is inferred to be multiplied by 1. But the 1 here is very helpful in terms of housekeeping and bookkeeping. So now, what I want to do is model this, and to do so, I'm going to model x plus 4 with one box of x, and I'm going to add to that 4 boxes of 1. Now, that we're going to be using the distributive property, which means that we're going to be taking 2 and multiplying each of the individual terms by such. Now, think about it this way. If we're going to be distributing 2 in each of the following terms, to multiply something by 2 means to simply double it. So if I'm going to double each of these following terms, I just am going to double the initial amount that was there. So I had 1 box of X here, and I'm going to double it. And I had 4 boxes of 1 here, and I'm going to double it. Now if you think of this little picture as its own arithmetic sum, if I have 1 box of X and another box of X, I have 2X here. And then if I have 4 boxes of 1 here plus another 4 boxes of 1, I get 8. Okay, and this is indeed our simplified expression when using the distributive property. Now, a question you might be asking yourself is, how can I check to make sure that I've done the distributive property correctly? Here's the answer to that. If I take the value of the term that I distributed and I got the outcome value, if I take that outcome value and divide it by the original outside value from the parentheses, and I get back my original value from before I distributed, then I know I've done the distributive property correctly. This is what I mean by that. If I have 2x here as my outcome value from the first term, and I divide it by the original value on the outside of the parentheses, which is 2. 2x divided by 2 is just 1x. Again, this is kind of an example of why putting that coefficient of 1 helps. Likewise, if I have a positive 8 and I divide it by positive 2, I do indeed get positive 4, which is the original second term. That's how you can check to make sure that you've done the distributive property correctly. Okay? So let's look at our next example. Now, up to this point, as I mentioned, things have been pretty positive. We haven't run into any negative values yet, but that unfortunately is not always going to be the case. So let's look at an example of what happens to the nature of the expression when it's multiplied by a negative value on the outside. So to do this, I'm going to take negative 4 times the quantity 8 minus 5. Okay, now just because this value is negative, it doesn't change the behavior of the distributive property. But remember, it's going to help to put these positive signs on values that don't have signs on them. But we're still going to be following the same idea. We're going to be distributing a negative 4 into both positive 8 and negative 5 by means of multiplication. A negative 4 times a positive 8 is a negative 32. Again, this is why things are going to get a little tricky now because of these negative values. Negative 4 times a negative 5 is a positive 20. Remember, a negative times a negative is a positive. Now, again, we're at this step where we're at an arithmetic sum to calculate. But before we do that, let's make sure we've done the distributive property correctly before we continue. If I take my outcome value from the first term after distributing, and I take that negative 32 and divide it by negative 4, I do indeed get positive 8, excuse me. That means that I've done that term correctly. If I take positive 20 and divide by negative 4, I do get negative 5, which means I've also done that term correctly. Now I can go ahead and do my arithmetic sum. Negative 32 plus 20 is indeed negative 12. Okay? Alright, let's look at our final example. And this example, what I'd like to illustrate is, so far things have been pretty friendly with the numbers that we've come across. But let's say we had the value 4.5 times the quantity of 16 plus 8. Now, what I'm going to do here is really kind of drill in the idea that when you see a decimal, one of the most beneficial things that you can do is directly right away change it into a fraction. Now, 4.5 is equal to 9 halves. But let's say, for intents and purposes, you didn't know how the decimal turned itself into a fraction. What you can do is remember, say any quantity is always over 1. It can be any value, it can be any decimal, it can be any variable. Any value or quantity is always over 1. Now, if we wanted to express this as a fraction, what I can do is to get rid of this decimal, multiply this by a factor of 10. Multiplying by any factor of 10 will allow you to move the decimal so many places to the right. But all we want to do is move it over until it's a whole number. So 4.5, all I need to do is move it over one place, and that's going to give me 45 over 10. Now all I have to do, now that I have a fraction, is to simplify it. And to reduce this, I'm going to divide the top and bottom by the greatest common factor of both values, being 5, which is going to give me 9 halves. And 4.5 is indeed 9 halves. Now let's go ahead, that we have that fraction to use, and go ahead and use the distributive property in the same nature as we have been so far. Again, remember, putting positive signs on any term that doesn't have a sign is very beneficial. So 9 halves times 16. 9 times 16 is 144. Divided by 2 is equal to 72. Likewise, 9 halves times 8 is going to be 72 halves, equaling 36. Now again, these values are positive, so make sure you go ahead and put those signs on each of those corresponding terms. But again, now we're at just an arithmetic sum. We have 72 plus 36. And that arithmetic sum is going to be 108. Okay? Now remember, as unfriendly and daunting as this looks, we can still use the same ways that we've checked in our other answers to make sure that it works. You just have to be careful here, because if you take 72 and divide it by the original value on the outside, remember that with fractions, it's going to be multiplying by the reciprocal instead of dividing. So 72 divided by 9 halves is the same as 72 times 2 ninths. And 72 times 2 ninths is indeed 144 over 9, which is indeed 16. Likewise, with 36 times, again, it's the reciprocal of 9 halves, which is going to be 2 ninths. And that's going to give me 72 over 9, which is indeed 8. And again, this allows us to check to make sure that we come up with our original values in the parentheses of the original expression of the terms. I'll reword that, I apologize. What we're basically doing is we're taking the outcome values, and when we divide by the outside value from the original expression before we distributed, and we get from that division the original values of the terms in the expression in parentheses, then we know we've done the distributive properly correctly. Alright? But our answer is going to be 108 after the arithmetic sum is taken. So just to recap a couple of things, guys, make sure that you always are making sure that you understand the signs of the values that you are being distributed. You can go ahead and put a coefficient of 1 on any variable that doesn't have a coefficient for bookkeeping and housekeeping purposes. But remember that the value that you are distributing into each of the individual terms, you are also distributing the sign on it. If you guys have any questions, never hesitate to contact or message me. If you have any special requests for any example problems of the distributive property, please also feel free to let me know. I'd be more than happy to do those for you. But I hope this video helps you guys out, and I hope you guys have a great rest of your day. Thanks for watching. Bye.